Hi, I'm Kate Lewis.
I'm Carolina Restrepo, and we're going to be talking about the brewing process.
And I'm going to be talking about the emissions that go along with it.
Okay, to start, the most important part of making beer is selecting the grains to be used. They're the ones that provide the aroma and flavor of beer. Some of the grains that can be used are rice, corn, rye, but the most popular one to be used is barley malt. The first step is to collect them and then crush them to expose the starch. After collecting the grains and crushing them, what comes next is the malting process. In this process, they're put in steeping tanks where they're soaked wet and then germinated in a week process.
And from that crushing process, we create a lot of particulate matter. So here, one of the main emissions is PM. Just because there's so much crushed material that gets into the airways and creates that PM emission.
After malting and germinating the seeds, the most important process is to pass them on to the malt kiln. Well, germination is terminated by drying the grains.
And in the malt kiln, this is another big PM emission spot. This preparation step in the brewing process is actually the place where the most particulate matter is created in the entire brewing process.
After drying the seeds can be transported to the brewery process in order to start the actual brewing process.
And in these two steps, even more particulate matter is produced. So these are the main brew house operations, and as you can see in black, these are the steps provided to us by the EPA website. And then in blue, you'll see different steps, and we actually got to go tour the Anheuser-Busch facility in Jacksonville. And in blue, you see the steps that they provided that they follow during their brewing process, and they directly match the EPA process.
The first step in the brewing process is the mashing process, where the grains and the malt are placed in a mash tun along with hot water, and sometimes a cereal cooker is used in the process. This is where the enzymes from the malt break down the starches and convert them into fermentable sugars. After the mashing process is done, the straining process begins, where the grains are turned into a strain master to separate the insoluble grains that are then further processed and converted to other products such as animal feed that can be then sold to make more profit.
And during this process, we have VOC emissions coming out of the mash tun and coming out of the cereal cooker. And during these brew house steps, this is where the main VOC emissions occur. And the main VOC emission that actually brew houses create is ethanol. And also out of the lauter tun or strain master, we have even more VOC emissions. And out of when we're doing the grain drying, just as in the previous step, we're creating a lot of PM emissions because of all of the grains mashed up in the air.
The mash that is usable after the straining process is now called wort, and it is transferred into a brew kettle where it is boiled with hot water along with hops to add flavor and structure to the beer. After the brew kettle process, the wort is then transferred into a settling tank where it is settled, and then to a wort cooler where it can be further cooled and then transferred into the fermenters.
Exactly. And from the brew kettle, we have more emissions. There are PM emissions here as well as VOC emissions. From the hot wort settling tank, we have some major VOC emissions. And lastly, from the wort cooler, we see even more VOC emissions. Now we are at the fermentation process.
The first step in the fermentation process is primary fermentation, where yeast are added to the worts in order to break down the fermented sugars into ethyl alcohol, carbon dioxide, and water.
So from the yeast propagation, we have some emissions. We mainly have VOC emissions from the yeast propagation, and then from the fermenters, we see VOC emissions once again. So from the fermenters, one interesting fact is that CO2 is produced, but it is not considered an emission because the brewing process is able to capture it and reuse it. So here we see that CO2 is produced, but we use a CO2 purification system to capture that CO2. And mainly, we're going to see activated carbon being used or wet scrubbers to capture that CO2. And then once the CO2 has been captured, we reuse it in the filling operations.
After the primary fermentation process, the yeast is separated from the beer and it can either be reused or disposed of. And if it is reused, it can go back into the primary fermentation process. After the beer is separated from the yeast, it goes into aging tanks where secondary fermentation occurs. After this process, it can be filtered to separate the solids out of the beer, and then the beer can be ready to be packaged and sent out to producers.
So some of the emissions that come from this step are during the brewer's yeast disposal or reuse. We see VOC emissions from this step. And then from the aging tanks and secondary fermentation, we yet again see VOC emissions. And the main VOCs that are being produced are ethanol. Throughout the whole brewing process, whenever there's a VOC produced, mainly we're talking about ethanol. And then after the beer is in the storage tanks, it goes on to packaging. And packaging is mainly just when you take the beer and put it into cans or kegs or anything that consumers can buy to consume the beer. And in the packaging step, our main emissions, once again, are going to be those VOCs or ethanol.
Hello everyone. Let's talk about the beer and brewery. Are you a fan of beer? As for me, I really love it. And as an engineer, when you are drinking a bottle of beer, have you ever thought about air pollution during the beer manufacturing? During a production process, there is possibility for emissions of air pollutants. Some of the main air pollutants receive attention, something like carbon dioxide, PM, volatile organic compounds, and ethanol emissions, etc. And the question is, how these pollutants affect human and environment? Now, assuming you have your answer, let's take two of these pollutants for example. They are PM and volatile organic compounds. PM means the particulate matter. And what we care about these days are PM10, which diameter is less than 10 micron, and PM2.5. Comparing with our hair, which is 60 micron in diameter. So we can see how tiny the particles are. When these particles are small enough, they may have chance to get into human's respiration system and get in deep into the lung. And after chronic exposure to these particles, it increases the risk for cardiovascular and respiratory diseases, such as asthma and cancer. When PM mixes with other chemicals like sulfur dioxide and they reach a certain amount, they can block the sunlight and form the haze, which will cause the visibility reduction. A famous example of this is the London fog. Now let's talk about another pollutant, VOCs. VOCs can attack the people through the eyes, nose, and the respiration system, and make people feel sick. But before that, we have to know the content level of VOCs, how long and how often you are exposed to the VOCs. And besides that, VOCs are important in the creation of smoke, and VOCs are also a reason for the global warming. That's all. Thank you for watching.
Let's take this intermission for a brief engineering joke. A definite integral walks into a bar and asks for 10 shots of whiskey. The bartender asks him, "Are you sure about that, buddy?" His response, "Yeah, I know my limits."
Have you guys ever wondered how we have such fresh, clean air in an ever-growing city with all this industry and automobile traffic all the time, every day, and construction still never stops? Well, I'd like to take a moment to thank big guy upstairs for giving us this fresh air. That's right, you guessed it. Thanking the EPA. up in headquarters in DC. Now, what's the Environmental Protection Agency have to do with a brewery? Well, you guessed it, protects our environment. So EPA manages the entire United States. So that's a lot of ground to cover. So they break it up into a couple regions to make it more manageable. But although they have all these political boundaries, air pollution knows no political boundaries. Now, on this map I've just put in front of you, you can see the entire United States broken up into the regions that EPA has declared to be Region 1, Region 2, all the way up to Region 10. Now, how does EPA make standards for all the different industries and stationary sources that are emitted all over the country? To manage air pollution nationwide, the Clean Air Act has required the EPA to set National Ambient Air Quality Standards, or NAAQS for short, for pollutants considered to be harmful to public health and the environment. Now, in the chart placed in front of you, you can see the 6 criteria pollutants that are considered to be harmful to the public health and the environment. The brewery we looked into, and actually the brewery process in general, only emits one major pollutant from these 6 criteria pollutants, and that's PM, or particulate matter. You can see there are 2 types of standards held for PM. There are primary standards and secondary standards. Primary standards provide public health protection, including protecting the health of sensitive populations such as asthmatics, children, and the elderly. Now, the secondary standards provide public welfare protections. And actually, as of 2014, FDEP has actually created another document which includes general pollutant limiting standards, and these include standards for VOCs, which is amazing to me because the National Ambient Air Quality Standards, which apply to all over the United States, doesn't account for VOCs. And the VOCs aid in the formation of ground-level ozone, which has detrimental health effects such as asthma, emphysema, chronic bronchitis, and continued damage to the lungs. So, if you weren't excited about regulations and permits before, I hope you are now. It's how we want to keep breathing in this wonderful, fresh, clean air, and hopefully we'll want to breathe in this air for the rest of our lives, for our children's lives, and for our kids' lives, and for their kids' lives. Now, I'll let our good friend Monica talk to you about pollutant capturing devices that can make reaching these emission standards possible. Thank you.
Hi, my name is Monica Camacho. You heard Vanessa talk about emission standards and regulations that must be followed by industries. Now, I'll be talking to you about what air pollution control devices are used by breweries in order to meet these standards. As Kate told you earlier, 2 main emissions from a brewery are particulate matter, which includes dust and other various particulates, as well as VOCs, the dominant being ethanol, which is primarily released from the barley malting process. So we have quite a few options on how to control for the particulate matter emissions. One of them being the cyclone, which is commonly used as a pre-cleaner. The fact is that it efficiently collects large particles. However, it doesn't normally meet the stringent air quality standards, so it's not normally used on its own. Secondly, you can use wet scrubbers, and that's very good for emissions that are highly explosive, flammable, or sticky. However, that's not the characteristics of emissions leaving a brewery, so it's not really relevant for a brewery to use. Then you have electrostatic precipitators, or ESPs, and this charges particles and then collects them by using an electric field. This is very good. It works well at removing finer particles. However, based on our research and analysis, we weren't able to find that many articles on its performance or uses in a beverage industry, so we don't know how its performance will really be in that setting. And lastly, you can use baghouse filters, which collects particles on the fabric of the filter. And this is used by many food industries, so it is known to be reliable. And it's also very efficient at collecting particulate matter of a range of sizes, and it's very inexpensive. One con is that particulates could become embedded in the fabric, thereby increasing the pressure head and overall increasing the operating costs of it. However, if it's maintained and replaced regularly, this should not be a problem. Now let's talk about some potential control devices for VOCs. One option that we have is activated carbon adsorption, in which the gaseous pollutants get adsorbed onto the carbon solid surface. Now, some good things to this is that some breweries already use this option. Also, it gives you the chance to sell the ethanol that you collect. However, the con is that it is expensive, so if you don't find a market for the ethanol, it could become pretty pricey. Another option that we have is a wet scrubber, which uses water spray to collect the soluble VOCs from the air. Now, this is very good because ethanol is highly water soluble, so it easily biodegrades in water. The con to this, though, is that it is very efficient, mainly at higher VOC concentrations. We also have the option of biological filtration, in which the gaseous pollutants get absorbed onto the moist biofilm. And on this biofilm, microorganisms start biodegrading the volatile organic compounds that get trapped into it. Now, some pros is that it's efficient for VOCs at a lower concentration, and it's also already being used at some beverage processing facilities, so it's known to work and be reliable. Another good thing, it has low operating and maintenance costs because it's pretty much self-regulating. The cons to this, though, is that it's not as efficient for if you have higher VOC concentration emissions. So finally, based on our research and analysis, we've come to the conclusion that for particulate matter, it's very effective to have baghouse filters treating the emissions with a cyclone pre-cleaner to remove those large particulates first. For VOCs, we recommend a combination of wet scrubbers and biological filters. So depending on what the concentration is of the VOC leaving the step, then you can either put a wet scrubber if it's a high VOC concentration or a biological filter if it's a low VOC concentration to get the most out of those devices.